Now in this part, when we're working with division of radical expression, if your denominator has an expression, in this case, in this example, 2 minus the square root of 3 in the denominator, that means that we're going to do a different process with rationalizing the denominator. In this process, we're going to multiply the numerator and denominator by the conjugate. So what I mean by the conjugate is that it's going to be the same expression but opposite sign. So again, I'm going to multiply, but now we're going to actually multiply what you see in the whole denominator of the example. So I'm going to multiply the numerator and denominator by 2, but instead of minus, it's going to be the opposite, which is plus and square root of 3. Over, same thing, 2 plus square root of 3. So you're going to multiply the denominator by its conjugate. So that's what we're going to do in the event you have an expression in the denominator, such as 2 minus the square root of 3. So here, we're actually going to have to FOIL in the denominator. So I'm going to write out what it looks like when you put it next to each other. So, as I stated, in the denominator, you're going to FOIL because it's a binomial multiplying with a binomial. But in the numerator, we're just going to basically distribute the 5 to the 2 and the square root of 3. So when I distribute the 5, I'm simply going to have 10 and plus 5 square root of 3. Now for the denominator, I'm going to FOIL. So first I'm going to do 2 times 2, which is 4. 2 times positive square root of 3, so positive 2 square root of 3. Then negative square root of 3 times 2 will be negative 2 square root of 3. And then negative square root of 3 times positive square root of 3 will be negative square root of 9. I simply multiplied the inside number and kept it inside the square root. All underneath. So I have this in the denominator. Now if you take a closer look, when we're combining like terms, these two terms, let me underline them. They both have the same radical, square root of 3, so you can combine them, and what you notice is that they both have the same number outside the square root of 3, but they have opposite sign. So these two terms will cancel out. So in my denominator, I'm simply going to have 4 minus square root of 9. And I'm still going to have 10 plus 5 square root of 3. So now, what we can do next is that you can simplify the square root of 9 because it's a perfect square. So we still going to have the numerator stay the same, so 10 plus 5 square root of 3 over, we still have that 4 and a minus, square root of 9 will equal to 3. So you can simplify the denominator while the numerator stays exactly the same. So 4 minus 3 is just going to be 1. And then you can still simplify that. If the denominator is 1, then your final answer is just the numerator. So 10 plus 5 square root of 3. And then let me box our final answer. So again, if your denominator is 1, then your final answer is just what you have in the numerator. So this is what you do when you're having an expression in the denominator of the example. You're going to multiply the conjugate. And again, the reason you multiply by the conjugate, meaning the opposite sign, is because you're going to have two terms in the middle with opposite sign. Therefore, they're going to cancel out, and you're going to be left with the first term and the last term. and the last term should always be able to do the square root of. In this case, you can do the square root of 9, which became 3. Now you can actually combine like terms. So in this example, we combine 4 minus 3, which equal to 1. And then from there, you should be able to simplify if you can. In this case, we did, and got 10 plus 5 square root of 3. So in this example, we have 4 minus 2 square root of 5 over 6 plus 3 square root of 7. So since we have an expression in the denominator, we're going to multiply it by the conjugate. So I'm going to multiply the numerator and denominator by 6 minus 3 square root of 7. And another 6 minus 3 square root of 7. So essentially, we're going to FOIL, but this time, since we have an expression in the numerator of the example, we're going to FOIL twice. Which is okay, it's just a little bit more work, as long as you're able to combine like terms, if you can, and then simplify, if you can. So, here, let's do the numerator first. 4 times 6, that's going to be 24. 4 times 3 square root of 7, since it's negative, it's going to be minus 12 square root of 7. And then here, I'm going to do this one. Negative 2 square root of 5 times 6, that's going to be negative 12 square root of 5. And then here, negative 2 square root of 5 times negative 3 square root of 7 is going to be positive 6, because the 2 times 3. Then inside the radical, 5 times 7, so it's going to be the square root of 35. Then we're going to work with the denominator. So let's take a look at the first part. 6 times 6, 36. 6 times negative 3 square root of 7 will be negative 18 square root of 7. Then the next part, positive 3 square root of 7 times 6 will be positive 18 square root of 7. And then positive 3 square root of 7 times negative 3 square root of 7 will be negative 9 square root of 49. Alright, so let's see if we have any like terms. In my numerator, I don't have any like terms to combine, so I'm just going to leave the numerator as is. But in my denominator, I do have two terms. These two middle terms, they both have square root of 7, so I can actually combine them. Now, again, you will notice that they will have the same number outside the radical, in this case the 18, but you also notice that they have opposite sign. So therefore, these two terms will cancel out, and then you're just going to be left with 36 minus 9 square root of 49. So again, the numerator stays the same. So let me rewrite the numerator down here. 24 minus 12 square root of 7 minus 12 square root of 5. And don't worry about putting this in order. 6 square root of 35 over 36 minus 9 square root of 49. Now here, you can actually simplify the square root of 49 because it's a perfect square number. So when you do that, and I'm going to write the work here since I'm running low on space. Here we're going to have, again, the numerator stays the same. 24 minus 12 square root of 7 minus 12 square root of 5 plus 6 square root of 35. I still have the 36 in the front minus 9, but don't forget, since square root of 7 was a perfect square number, then I'm going to multiply the 9 by 7. So the square root of 49 became 7. And don't forget, since we had the 9 in the front, that means that whatever comes out from the radical, so in this case, square root of 49 became 7, the 7 will multiply with the negative 9. So, like I said, the numerator stays the same. 24 minus 12 square root of 7 minus 12 square root of 5 plus 6 square root of 35 over 36 minus 63. So here, you actually have to work out 36 minus 63. So, again, there's nothing you can do in the numerator, so it stays exactly the same. 24 minus 12 square root of 7 minus 12 square root of 5 plus 6 square root of 35. But in the denominator, 36 minus 63, that's going to be negative 37. Now since it's negative, I'm simply going to move the negative in front of the fraction and then get rid of that. So my final answer is negative 24 minus 12 square root of 7 minus 12 square root of 5 plus 6 square root of 35 over 37. There's nothing I can do to simplify, so this will be my final answer. And let me box that up. Now one thing you have to consider is that if in the example your numerator is an expression like 4 minus 2 square root of 5 and you're going to multiply the example by the conjugate, be prepared to have multiple parts in the numerator. Now, had the denominator become or came out as an even number, then you can actually simplify the fraction because the 24, the 12, and the 6 are all even number, and if the denominator was an even number, then all parts would be divisible by 2. So it's something to consider. Always check if you can. And again, any number, well in this case all numbers that are outside the radical, if you can simplify them, go ahead and do so. But make sure you simplify it correctly.